Here's a few news articles that are kind of interesting. This is, we had a law enforcement guy here, a forensic guy from the San Francisco police, and he mentioned he uses this. Because I said, what if somebody has a locked phone and he uses Gray Key? I wondered if he would use Celebrite, but I think Celebrite is too expensive. Celebrite, I was with them in Sri Lanka, the CEO of Celebrite, and he announced there, apparently for the first time, he was like cagey the first time I asked him, and then he decided to just come out of the closet and admit, Celebrite can hack into anything. Any version of the iPhone, any version of Android, they can blow past it all. Gray Key, I think, can only do certain versions. And Gray Key's been around for a long time. I think it's a lot cheaper and simpler. Gray Key just tries all the passcodes, and it found some way to erase the counter so it doesn't ever count your guesses. So it can just try hundreds of guesses, and after hours it gets in. But that only works, I think, on older versions of the iPhone. Anyway, so this one I thought was kind of funny. There's a famous Twitter person called Security Swift on security revealed a ZeroDay, or other people are calling it this. I probably would have done the same thing. He found a, what is this garbage? There. He found a flaw in the product, but it didn't seem important, so he just mentioned it here. What they did is there's a DNS rebinding attack that we've been talking about. A lot of home devices, if you're on the home network, they assume you're the administrator, and they don't require further authentication. But for some reason, these guys have defined a domain just to go back to 127.0.0.1. So you go to the cloud, and then it bounces back to 127.0.0.1. So that's weird. Oh, thank you. Anyway, it's that is, and it turns out some people think you can exploit something through this. The guy that tweeted it out, of course, thought it was not important. Anyway, so let me go on to a few others here. Good, I'm glad some people showed up because we'll have fun with these pies anyway. So you can get a master's from SANS, which would be very expensive, but you'd be able to spend your military grant money on it. So that sounds like a great idea to me. SANS got themselves accredited at a college. Which makes me wonder if we should just get our corporation accredited at a college. Apparently, it's not that hard to do. Anyway, then we could offer degrees. Anyway, but these guys are already offering degrees, and nobody, I think, will argue about a degree from SANS. You get like 8 SANS certificates, and you get a master's degree. That sounds pretty good, except it costs like $50,000 or $60,000. But if you have like a GI grant, they'll pay most of that. That would be a pretty good choice, I would think. This is China's Great Firewall is an offensive weapon as well as a content filtering tool. The most famous thing people talk about in America is it prevents you from reading news and using American social networks and stuff so that they can prevent you from seeing information they don't want you to see. But it can also be used to attack people, and has been several times, and now they're attacking Hong Kong with it. Because, you know, they want to black out Hong Kong so people don't see what they're doing. The protesters there. I've been listening to a lot of podcasts, and most people say, the head of the China Daily News was on a podcast talking about this, and he said several very interesting things. He said that the Hong Kong stock market falls more when Trump says something about the sanctions against China than it does when there are protests. The protests, even though they're shutting down the airport, are a minor blip. The main thing there is they wish America and China would get along because they're in the middle, and their entire economy is based on shipping goods between America and China, and this trade war is very, very bad for them. And anyway, he said it is widely believed in China that the Hong Kong protests are being driven by America, and perhaps not deliberately in the sense of CIA provocateurs, but indirectly by creating a climate where people think this kind of protest will do something, which I think is entirely true. We have created the feeling that you can accomplish something with this. And he said that China cannot afford to just bring in the military and crush them the way they did in Tiananmen Square, which surprises me. That's what I'm expecting any moment. They'll just bring in tanks and soldiers and kill a bunch of them, and that'll be the end of that. But they, at least the head of the China Daily News in Hong Kong, thinks they can't do that because they're waiting for the 50 years of the Hong Kong protectorate to expire. He's closer to it. I don't think that's going to stop him. I don't see why that would stop him. Nobody seems to really care about living up to treaties or anything anymore. But anyway, we'll see what comes of it all. Yeah. Why not? Why would they care? The only thing that would stop them is if the U.S. cared. What? They want to bring Taiwan back.
So, you know, once
So why don't they just?
then Taiwan stop.
Oh, you think so? Yeah. They wouldn't just invade Taiwan and take it by force?
It could be very expensive.
Really?
Yeah, it's going to be, you know, like a city by city warfare. It's going to be very expensive.
Well, you don't think the people would just give up and acquiesce? I mean, they're going to go to China anyway in 50 years.
Taiwan, all the male people, you know, the men, they all have military training. So.
Well, okay, but are they really okay? Then what are they going to do in 30 years when it expires and they officially become part of China anyway? I mean, it seems like a lost cause.
You know, they just keep it like that.
Ah, well.
You know, in the 80s, the U.S. Bought Taiwan and tried to get it off, and then Taiwan just say we will join back. You know, once China is democracy, so once it's not there.
Well, that's very interesting. I certainly hope that happens that way. The people are close to it. Yeah. Oh, what about it?
How does it work?
Oh, it takes all the traffic that hits the firewall and causes all those nodes to attack a server. So it just creates a lot of traffic. You can use it not just to block traffic, but to reflect traffic back. That's an old trick. H.G. Moore did that one time. Cloudflare talked about doing it. If you get attacked, one thing you can do is bounce the attack back and hurt somebody else. And basically, they have so much traffic coming in, they can use that as attack traffic. Anyway, so Evil Corp is out there, and there's a $5 million bounty on this guy, so I guess he's hiding outside the U.S., and they haven't been able to catch him yet.
There's only one guy?
Two guys are the main ones. It looks like maybe there's four, but there's two main guys that got indicted, and they have a ridiculous lifestyle. They be posting pictures of them riding around in their mansions and fancy cars and stuff. Yeah, they live like this has been the case for spam kings in Russia for decades. They are basically the heads of criminal empires like the mafia, and they live in ridiculous luxury like a James Bond villain. So anyway. This guy points out something which I've certainly heard, and he's an expert in the field, is quantum computers are probably pretty much garbage. They're never really going to crack RSA or anything. That's what I kind of expect. The problem is, in principle, quantum computers could be fast, but in practice, the bits are noisy. And any attempt to make the noise go down is incredibly expensive. And you couldn't really crack anything important unless they make the noise like 1,000,000 times less than it is. And the error correcting techniques used for digital data will not work on quantum data. So he thinks we may never overcome that problem. Of course, there's always a steady drumbeat of people saying, well, this is the end of Moore's law. We've hit a problem miniaturizing computers and we'll never solve it. And then they always find some way to get around it. So, you know, the odds seem to be against any such prediction that any advance won't happen. But this particular advance may not happen. Yeah. IBM's doing it. Google's doing it. DWeb's doing it. China's doing it. Everybody's doing it. Everybody's putting development money into it on the chance that it will turn out to be great. But what we have now is not great. And everyone's assuming that it will get a lot better. And of course, there are people saying it won't get a lot better. There always have been. So only time will tell. Yeah.
Let's say IBM or China somehow breaks through with quantum computing. What's your opinion on that, Professor?
Oh, well, I don't have any strong opinion. My only theory is that since the NSA gave a very sudden warning and they reversed their direction on cryptography about 4 years ago, I think they have one. That's why that was my personal opinion. They would not have delivered such an angry, immediate warning if it was just a theoretical thing 20 years. I imagine the NSA already has one, but it's only highly classified. That secret stuff is usually 20 years ahead of the public stuff. I don't have any security clearance. I have no knowledge inside the NSA, and if I did, I of course wouldn't be able to say, but I don't. But I'm just from experience, they usually have things 20 years before it leaks out or is reinvented on the public side. And so that makes me think it probably is possible and is coming. But I'm just basing that on sort of political guesses. There are serious technical hurdles to overcome. And it may be that they never reach the point where they're affordable or work very well. Anyway, so this was pretty interesting. Many people have been petitioning San Francisco to give us money to save the classes, and the chancellor went there and told them we do not want the money. There is no emergency. This is just fine. And the rumors I'm hearing are that he's What's really going on is they want to build like housing projects on the land. So they're just getting rid of the college to free up the land. I thought that was crazy when I started hearing those rumors, but it looks more and more like that because the accreditation woman was clearly bribed by somebody to just demand to close this with no evidence. And the chancellor appears to be bribed by somebody to just close this for no reason and refuse money that's available. It does seem like he's taking orders from somebody else that's not us.
Who get money for the other side of the parking lot? That's really development.
Yeah, they've got money to spend on things, but they don't have money for classes or teachers. Anyway, but they've announced that they're not going to have any more cuts next semester. Although they also announced they're refusing the money from the city that was necessary to make that possible. So as usual, nothing makes any sense. Nothing around here ever makes any sense. It's very much like the federal government in Washington. Everything they tell us makes no sense, and obviously they don't tell us much of what's really happening. So God knows. But apparently they're not going to cut more classes. It would be sort of late to cut classes now. Theoretically, you won't cut any more classes except the usual nonsense, how in the first couple of weeks of class, they cut everything that doesn't have enough enrollment. But we're pretty used to that. But apparently, they've been cutting hundreds of classes in addition to that, and apparently not going to do that again. Anyway, that's enough of this stuff. I want to talk about ARM exploits. I'm glad to see several of you make it here. So I've been trying to move the 127 class into ARM, and it's going quite well in one regard. So I put the new projects right here. And we're going to do these two tonight, ARM shellcode and self-modifying shellcode. And I have a bunch of pies, we'll set them up. And also started putting them in the cloud. I got one in the cloud. I found out how to make reverse SSH shells, so I can put them here behind NAT, and they can have a presence in the cloud and people can remotely control them, which is awesome. That means I don't have to lug them all to Dubai and Paris and all the places I'm going to be teaching. And I can put them in my own cloud. So we got a whole stack of these things just sitting there. So anyway, these pies are awesome. So let me start talking about the Pi. The Pi is just this little gadget with a simple chip, and it runs ARM 32-bit. These are older Pis. These are 32-bit Pis. There are newer 64-bit Pis, and I think I might get some of them too to the 64-bit. And I put them in the cloud. So let me just connect to my cloud machines. I have one of them in the cloud, and in fact, a lot of students could share these ones in the cloud. The students in the classroom, you might as well set up your own. I'll show you how to do that if you haven't done it before. It's kind of fun. But the people that are remote may wish to just connect in the cloud. So what I did was I just figured this out today. I can have a machine inside NAT, and it can make an outgoing SSH connection, and it can create port forwarding. So it connects to a remote server, starts listening on the remote server, and all that traffic forwards back to the local device. It's called a reverse SSH shell, which is pretty awesome, and it works. So you make an SSH connection to a remote server, and you tell it to listen on a port on the remote server and suck all that traffic back down locally. SSH supports this. You have to make a couple configuration changes in the configuration file on the server to allow this. And you have to have certificate authentication because there's no way to put in a password. But once you do that, you can have a server locally. There used to be cloud services like No IP was an old one. You would install this software and you could have a domain and run a web server locally behind NAT, but you really don't need it. With SSH, you can do the same thing. And so I put it in a cron job on the Pi, and it connects automatically when it hangs up. And it took me a while to get it working, but it was working before class, and it's still working. So life is good. So you connect to this thing. Now the default username is Pi, and the default password is Raspberry. And since I put it in the cloud, I wasn't willing to just leave it at default, so I changed it to not Raspberry. It's not all that secure because obviously everybody's going to have root on it, everybody listening to this, so they'll probably get hacked and stuff, but you know, that's life. And like all my target servers, they tend to be vulnerable. So now I'm in. Once I'm in, this is Raspberry. And by the way, you can see the desktop. I forwarded the VNC also. So you can install this thing called VNC Viewer, and then I just have to go to that address, which is this one, I think, and just connect, and now I can have a graphical desktop. So this is glorious Raspbian. It is a port of Debian, so it looks like Ubuntu, it works like Ubuntu. It's very simple. Now, when you get a brand new Pi, you have to snap together 3 or 4 pieces. They're made out of plastic, like building a little Tinker Toy. And then, for some reason, when you turn it on, it doesn't have any useful networking. So you have to actually connect it with a big HDMI cable. You can connect to a monitor, and you have to plug the USB keyboard and mouse, which is very, very annoying. You have to actually go to all this heavy junk just once. And once you've done it, you don't need to do it anymore, because you go in here, you go in Preferences and Configuration, and now you can turn on network services like SSH and VNC. So you can have a command line shared remotely over a wireless or wired Ethernet. And now, of course, the problem is the wired Ethernet will connect, but none of these things are listening. So it's very, very annoying. You have to have the access to these big, bulky, stupid things once. And which kind of undoes the whole point of it being miniature, but that's the way life is. Anyway, and then once you turn these things on, you can then connect remotely and get the graphical desktop, and you need the graphical desktop to do this. Although you probably could do it in the command line, you have to connect to Wi-Fi somehow. And if you connect in a coffee house or something, almost everybody has isolation mode turned on. So even if you connect, you can't get to it from another machine. So anyway, for a while, there are various techniques. Anyway, I connect to Danger Zone, which is our local unfiltered Wi-Fi, so everybody can just get here locally in the room. That's how I did it for a while. But I just did that long enough to install my script that pumps it up to the cloud. Now everybody goes up to the cloud, to my attack server, and back down. And so it's available to the whole world. So you've got a terminal here, and this is just like Ubuntu. You got apt-get, you got ifconfig, you got all the usual stuff. And I can shrink this a bit. Well, I thought I could shrink it. I guess not with Control minus. Let's see, edit, preferences, font. There, I can change the font to something smaller and say okay. And looks like I need to hit like an OK button I can't reach or something. Right. This happens with Microsoft too. You have a screen that is too small to see the things you have to click. Well, I'm not going to worry about that, because the only reason I need to do that is to get command line. You don't need to do command line in the GUI anyway, and I can't reach the button to close it either. So let me just close this nonsense. We're on the Wi-Fi, so we don't need the graphical environment anymore, and I can do it all from here. So here I've got a nice SSH shell, and I can see what's happening on here. So let me just show you the joy of this project, which is working out pretty well. So I'm going to make a directory for demo and go in there. I'll have a bunch of students sharing the same device, so you might as well have your own folder. And now we can make a vulnerable program. Now, originally I was going to have a program that has a standard buffer overflow coming in from text. As you're going to see, that turned out to be far, far more difficult than I had anticipated. So I made a much more complicated program that accepts raw hexadecimal. So you can put in null bytes and everything. This is pretty much what's running in part of ED 30202, which you did a long time ago. So this is PWD, so nano PWD3 I called it, .c. And I can just put in this C code, and I can use all my shortcuts, like go to the top. So what this does is it takes a password and it comes in hex, like 41, 42, 43, and you can have it, and then it's going to parse it. That's what all this hex2 raw thing does. There isn't like a standard C utility to do this as far as I can tell, so I just had to write my own that hunts through and builds the hex. And so that does that. And then it goes here to test PW, which is just the same old thing. It only has room for 10, but it copies in something without regard for length. And it does not use string copy, because that would terminate at nulls. It uses memcopy. So it copies a block of data, even if it has null bytes or anything in it. So we can use any kind of junky code at all for what we're doing here, which is the way to start. All right, and so all this does is it calls hex to raw to turn your hex input into raw, and then it calls test password, and then it prints all done. And of course, there's a buffer overflow here, so if you exploit it, it may never come back from that. And I printed out several addresses so we can see what addresses are randomized. Yeah.
What do you mean by raw?
Raw data comes in as, well, you put in hex, like 41, 42, 43. It converts it into raw strings by taking 2 characters, like 41, and turning it into 1 byte. And that's raw binary data, but it's not really a string in the C sense, because it's not null terminated. It can have embedded nulls. So it's just raw binary data. And that's why I use memcopy. Anyways, that's what that is. And now you can compile this thing the way we usually do. If you use -G, you get source code, so you can do source code debugging. And so I make the output PWD3, and I read in PW3.c, and it compiles. So if I run that, it asks me for a password, and if I give it 41, it works and doesn't crash. But if I give it a lot of stuff, like 41, 41, Then it took that, but at some point it won't. So I think if I put in twice that, that'd probably be enough. Yeah, now I get bus error, whatever that's about. But at some point, basically I'm getting a seg fault and an overrun and so on. That's the fun thing. So now we can watch it in the debuggers. Let's do that. You have the same old debugger, GDB, it's running on ARM. So if I do this and look at PWD3, and then I start by just running it, and then I put in that stuff, like 2 of those, then it's going to crash. And see, we've seen this before. 42, 42, 42 ended up in the EIP. Now you can put a breakpoint in. Let's this is a good trick. You can put a break at start with an underline. There's always a start to start the program. And now you can run it and start over. Now it's going to start and hit the breakpoint right away and stop so I can see things. So now I can list the code. And it's going to, it shows code, I think, near where I am, or maybe it just remembers, but it shows the interesting part of the code. This is where the buffer overflow is. So as usual, I want a breakpoint after that. And I think I'm just going to put it down here. I could put it in any of those lines and it would be all right, but I'm going to put it here on 46. Okay, and now I'm going to run and say yes. And for starters, I'm going to put in a short password of just 4 capital A's, 41. And now, oops, oh, it hit the breakpoint. I got to continue past this breakpoint. That's the start. Continue. Okay, now it's ready for a password. Okay, and now I did not have an overflow, so I can examine the state of this processor. So let's do info registers, and you can see the glorious ARM registers. You got R1 through R12, and then stack pointer, and this link register is used to return for subroutines, and then the program counter. And then I don't know what this junk is. But anyway, that's the and these registers are all used for general purposes. The only thing that matters to us is that R7 is used for system calls. Now remember, in x86, it was int80 to call the kernel. Here it is SVC 0 to call the kernel. It has a parameter there in the command, which is not used and serves no purpose as far as I can tell. And the real data goes in R7 is the number of the function you're calling, and all the rest, R0 through R6, are the parameters. And that's it. You can now call all the C system libraries like print and everything. So that's how you do it. And we can look at the code. I can disassemble main, for example, and you will see the raw code here. This is the ARM assembly code that does it. One interesting, you can also disassemble with the /R, which is quite helpful because it shows you the raw hex. So you have the interpreted assembly code here, and here's the raw hex, and here's something you talked about before. In ARM, every instruction is always 32 bits big. And the first thing I thought when I saw that is that means you can't refer to an address in memory that's 32 bits. You can't have an opcode and then 32 bits of address, and that is absolutely true. If you try to refer to immediate values in ARM, you cannot refer to arbitrary immediate values. There's not enough data there to take them. Only certain values are allowed, and we're going to hit that later. Anyway, everything's 32 bits wide. That's a little bit strange. This BL is how you call something and return. B will call something, it's branch unconditionally. It will call something and never come back. BL will branch, and then remember, I think in the link register or something, how to come back. That's the equivalent of call, subroutine. Anyway, so this is what branches down to hex2 raw and comes back. This goes to test PW and come back. And this goes to some system call, which I think is like exit or something, and then you're done. Pops R11 from into PC, or else pops both of these off the stack, R11 and PC. R11 is the equivalent of EBP for the stack frame, and PC is the equivalent of ESP. So this is the returning from a subroutine. Pop those 2 values off the stack. So now let's look at the stack, which is x50x stack pointer. And here's the stack. As we usually see it, here's the AAAA we put in. Then a few bytes long, this is the program counter. Notice back here, we jump to test PW, and when we come back, we're going to be going to 108.38. So this is 108.38. That is the return address. And before it is the saved EBP, which is what goes in R11. And you can see right there, it's going to put that in R11. So if you actually wanted to make a graceful exploit that would let you then resume code, you'd have to also fix R11. For what we're doing, it's enough to just hit the program counter and trash R11. It's okay. All right, so now if I just continue now, it's going to succeed because I haven't trashed these values. So that short password is accepted. But if I run it again, well, I can just type run, too much bother to find where it is. And now hit breakpoint and continue through this one. And here I can put in, whoa, lowercase letters work better, 41. All right, that's a password more or less. And now if I do info registered, there's nothing too important here, except you can see that the stack pointer is, by the way, up here at 7EFF, and the other code is down at 100, at 10,000. And if I look at the stack, which is x50x, stack pointer, here you can see I have overridden the program counter with 45, 45, 45, 45. So now I can do the simple program where I reuse code. We can do that, but you now control that pointer. So if I just continue here, it's going to crash, of course. And if I can find a useful value to put there, then it will execute that code. So let's go back to my instructions and see. So now we can start planning the exploit. That's what we've just done. We've now figured out how to do it. So we can put any value we want there. So if what I might want to do is just keep overflowing the buffer down to here and run code down there. Now, as usual, it turns out that inside the debugger, the addresses are different than outside the debugger. So I decided to put in a NOP sled. Now, here's a sort of stupid thing. There is no NOP in R. I don't know why, but there are instructions that happen to do nothing. So we'll use one of them. They're technically not considered NOPs though, but there's an instruction called move R0 to R0, which of course does nothing, but it's technically not a NOP. Anyway, there's always these details. So now we can, now the next thing is address space layout randomization. Remember I said I put in some addresses in here so we can see what's going on. So if I just put in a password of 41, okay, so the password is here at 7EFFF274. If I do it again, it's 7EFF274. So my address space layout randomization is already turned off because I put this in the cloud and I haven't had to reboot it for a while. You can turn it on and off exactly the same way we always have. You just control this thing, process kernel randomized VI space. It's on by default and you can turn it off. And I've already turned it off for this particular Raspberry Pi. So that's one irritation we are not going to overcome in the projects today, although we can totally get there. We have all the things we need for it. So now we can talk about Linux system calls. Linux system calls are independent of your hardware largely, but there is a chart that shows how they're implemented on each hardware. But the basic Linux kernel, the whole point of it was to be hardware independent. So here's the functions we're going to have. And like I said, the only thing that matters to us is the R7, which is the system call number. And then we might use other registers like R0, R1, and R2 for parameters, for functions that need parameters. And we're only going to use a few system calls. There are hundreds of them, of course. There's write that writes to the keyboard or elsewhere, writes to the screen. And there's exit, which exits cleanly instead of just crashing at the end. And there's execve, we've used before, which launches a new process and does not return. And then there's all these Berkeley socket functions, socket bind, listen, accept, that we'll use to open a listening socket or remote shell. And then there's duplicate that duplicates a socket handle, which you need in order to properly use those other things. I was reading an article and they're saying everybody's finally getting really fed up with Berkeley standard sockets. They say it's really, really annoying to write like a server that has to loop around listening for stuff. And they're trying to invent some new, less irritating system. But this dates from a long, long time ago. It made the internet this whole raw socket thing, the same in every language and kind of a pain in every language, but yeah, you get used to copying like the 50 lines it takes to make a listener. And anyway, so first we're going to make hello shellcode. So I'm going to call it write.s. And this is shellcode that's just going to print out something so I can see that it's working. So I make write.s and I put in this junk and I forgot a dot at the start. I didn't copy it very well. All right, so you have a text section and there is no data section or anything. I have some extra spaces here that don't hurt anything, but they're ugly, so I get rid of them. All right, so here's text, and you can put labels in it with a colon. So I have a label called start, which tells it where to start, and I need a label called exit, although there's no real reason to. I just copied this from somebody and modified it. Here's ASCII, here's hello with just hello and a null byte at the end. So this is a raw string, and it's in the text section right after the code. You can put data there. It's kind of sleazy and not recommended, but you can do it if you're a slob and you just don't care. You can just put data right there instead of having a separate data section or anything. So what this is going to do is it's going to put 1 in R0. This is going to put the address of the hello label in register 1, which is nice. I don't have to like find it. By the way, I should mention something that really will give you a headache. The program counter is wrong. Another place people do this, when you actually look at what's actually implemented here, it is like program counter plus 8. And the reason it does that is because ARM at some point in its history was pipelined. So there are 3 instructions. One instruction was being executed, another was being interpreted, and a third was being loaded. So by the time you execute something, the program counter has gone 8 bytes further. So if you calculate from the program counter, you have to add 8 bytes and then add like another 8 to get moved down 16. So all the addresses are relative to the program counter in order to make code portable for address space layout randomization, and they're all wrong by 8 bytes. And as we're going to see, if you're in thumb mode, they're all wrong by 4 bytes, just to give you a big headache. So anyway, I decided to simplify my code and let the assembler do it for me. So I used fixed addresses like this. Another fun thing, by the way, is these labels cannot be at just any memory address. They must be on 32-bit boundaries, which of course is no problem right now because everything is 32 bits big. It's going to be a problem later when we go to thumb mode. Yeah.
How many bit is the thumb mode?
16 bits. And therefore you have to have an even number of instructions before the data, or have a data section, which is what you're supposed to do. You're not really supposed to just stick data right here in the middle of your code unless you're totally sleazy. But shellcode is typically very sleazy because you're just trying to make it small as possible and simple as possible, and you're breaking all kinds of good programming rules to accomplish that. So anyway, so this is going to load the address of hello in the register, and this is the number of bytes to print, 6 bytes, including the null byte for some silly reason. And this is the syscall. The right syscall is 4. So this is syscall 4 to the standard out, which is 1, printing that string and that many bytes. And here's the syscall, service 0. That's syscall. So that's 1 that executes write. And this is exit. I just load number 1 is exit, and I call it, and I don't need any other parameters for exit. So this is exactly like what we did when we started writing x86 assembly code. We did this way back, like in like 3 or 4 weeks into the class, raw, just simple exit shellcode. And so this should print that and exit. So let's give it a shot. Now we assemble it with AS right here. You assemble the source code and you put the output in object code. So write.s turns into write.o, and then you have to link it. So you link that with LD to connect it to libraries and the system and so on. And that has the same syntax. You link it, you take the write.object and you turn it into write, which is executable. And now you can run write, and it prints, well, if you don't make extra characters in the command line, it prints hello. And I'm so sleazy, I didn't even put a character turn after the hello. So, you know, this proves that I can write, but there's nothing very elegant about it. And now we can see what did that. We can do obj dump, for example, our old friend. We've used this a lot in this class. And we can look at the write executable. And you'll see, here it is. This is the whole bloody thing, ELF 32-bit. Little ARM, there are different versions of ARM. I don't know which one we have. And so here is the start. Here is the move that goes to the first service call. Here's the exit. So here's the start, exit, and hello. The labels are there. So here's the raw hello, H-E-L-L-O null byte. And so it tried to interpret that as some kind of instruction, which of course it isn't. It's text. So this is all garbage, but the raw bytes are there. And you can see, yeah.
Hello string has six bytes in there?
Yeah, 5 bytes and the null byte. For some reason, you count the null byte. I don't know why they even asked for the length if it's got a null byte, but you know, I think because C is null terminated, but assembler is not. Assembler doesn't know that nulls are anything different than anything else, I guess. But I don't know. Anyway, you have to put in 6 bytes so it prints the null. I don't know what would happen if you put in 5. Seems like it would work just as well. Might be fun to try. Anyway, so one thing that's funny is you have things like this service 000, and notice I have a 32-bit number here, but I only have 24 bits to put it in. So like I say, not all numbers are in fact usable. But anyway, here's another annoying thing. This is all full of null bytes. I could never inject this into a string variable. It wouldn't run. So But anyway, it does run here, and I can, of course, exploit my program with it because I carefully wrote a program that will let me use null bytes. So I want to get all this hexadecimal stuff without all the interpretation. So you can do that with this XXD. You do object copy to get just the active ingredient out of the binary, not a little linking to the operating system and such. And then you use XXD, you can print it out in various formats, and printing it out in PostScript format turns out to do just what we want. It gives you raw hexadecimal. So I object copy it, creating a new file called write.bin, and then I print that out in PostScript format, and there you have it, just raw hex of my shellcode. And you can see it's just going to do exactly what that junk does. So I can put that stuff in Python, and that's what I've done here. So now I make a Python file. I called it pwd3a. So let's nano pwd3a.py. And there it is. I just have a prefix, which is AAA, BBB, CCC, DDDD. The next 4 bytes are going to go in the program counter. So that has to be 7E, FF, F2, B0, because that was the address that jumps down the stack some distance. And it's all highlighted back here in this figure there. That's this address down there. So I've had this, I have 4 32-bit words of junk to fill the space. Then I have the program counter here, which I set equal to that value. So now I'm going to put in a NOP sled and then my egg. Here's a NOP. This is one of those commands that does nothing. I think it moves R1 to R1 or R8 to R8 or something. E8, A0, 10, O1 is the come. So this, I kept 30 of those. And then I have the buffer, just that binary that came from PS, and that's it. I print the PF prefix, the EIP, the NOP sled, and the buffer. And so this string, when put in as a password, should exploit the program. So I save that, and now I should be able to run it with just Python. pwd3a. Okay, and there it comes printing out that junk. And I could pipe it into the program, or I could copy and paste it. I think I'll copy and paste it. In this case, I have luxuries like this because it's not unprintable, because I'm using this hex format, which is not standard, but it's simpler to work with, of course. So we're going to go in password 3. If I put in that junk, it prints hello and exits, and never comes back to print you're done, because it doesn't really recover and come back and resume program. This is the sloppy attacks we've been doing all semester that actually break things and no longer do their original function, but we can see them go. So now we can take a look at that in the debugger if you want to. I don't know if there's any real need to. We understand it pretty much how it's going to work. So, all right. So we've seen all that. And anyway, this, however, is interesting. If you've been paying attention, you should be rebellious. This should not have worked. We ran code that was in the stack. What happened to data execution prevention? Why isn't it there? It should be there. As a matter of fact, it should be in all modern versions of Linux, but it's not in the Raspberry Pi, and this is a known defect. You can see the configurations of the section, where they're just looking at cat proc. So let me try doing this live. It's something I learned how to do. So if I run pwd3, if I want to do something else while this is happening, I could open another terminal, or I can use the ampersand here. This is an old trick from the days when you had a printed paper terminal and you had no way to open another terminal. You had to somehow do 2 processes. This means run it in the background. So it runs it, and now it's asking a question, and if I press enter, it will let me do something else while that process is running. And that process is 4214. So I should be able to look at the process. Every process in Linux has a process ID, and it has the maps are here. So this is the memory map of that process, and you've seen it in debuggers like Immunity. It's just right there in Linux. You don't need a tool at all. You can just see it. It's right there in the file system. So here's all the sections. So here's part of the password, here's part of the password, and here's the stack. And here are the permissions, and the stack is read, write, execute. And I don't know what the P is, but it's read, write, execute, which is not allowed for anything in Windows or any other modern system. Yeah?
Is there a way to turn on EP in Raspberry Pi?
Not as far as I know. I think in order to get it, you'd have to have SE Linux, and Raspberry Pi doesn't support it. I don't know. But this is actually, excuse me, there is. This is actually a defect in one of the configuration files used to compile Raspbian. And somebody found it and said, you know, you could recompile Raspbian and just fix that, and they really ought to, but They haven't, and it's just a no defect. But this is the thing about the Internet of Things. You've heard it all along. Now we're seeing it more live. These Internet of these little things is really crappy for security because they make all kinds of approximations and use really old stuff and shrink it down. And, you know, it's pretty, so we can totally modify code in the stack and execute it. Anyway, so that's good, clean fun. So now we can make exec VE shellcode the same way. This is actually shorter. You call the exec VE syscall, which is number 11, and now you have to give it a command to run, and you just have a command, /bin/sa/0, and that runs and launches a shell. And then we can make a bind shell, which is where the real fun comes. It is actually pretty complicated, but we were able to do it because other people have set it up for us and showed us how to do it. I'm just copying somebody else's code with considerable modifications. By the way, you can't do anything like this in that stinking emulator. GDB crashes, half of these exploits crash, half the commands don't work until you just want to cry. On the real hardware, it runs just fine. I thought I was going out of my mind. Anyway, so bind.s looks like this. And as I mentioned, many people are kind of fed up with Berkeley sockets because they are so annoying to use. So to bind, you have to define a socket, then call bind to bind it to an address and a port. And then you have to call listen to listen on it, and then accept to accept connections. And then you have to have 3 copies of the pointer for some stupid reason. And then you call exec VE to bind a shell to it. That's all the things you have to do to make a bind shell code. And so this is the stuff that does all that. There are a couple of strange things that happen here. I can't put 284, which is the number for this call, in R7 because 284 is a number you're not allowed to refer to all at once. You can only refer to numbers up to 1 byte, and you have like 4 more bits after that, which are used to like shift it or something. So there are some high numbers you can use, but not all of them. It's like mind bending. So if you want to put 284 in the register, the way to do it without going nuts is putting 200 and then add 84. Like I say, this is the thing about reduced instruction set computing. Instead of having all the instructions to do what you want, you have a strange, limited, small set of instructions, and you often have to take 2 or 3 instructions to add up to what would seem like one action.
Have you reached do you know the limit, or do you want to test out how far we can go?
No, I found the ARM reference manual, and it tells you, and I really didn't pay any damn attention. All I found is all numbers are good up to 255, and that's enough for me. I don't really care after that. But, you know, I'm just racing to the end. There are manuals, and there are rules, and there are people figuring out clever tricks. And the original shellcode here, the guy would load something and then add 1 to it and add 2 to it, so we get these. I tried to make this as clear as possible, make it simpler. But I was real glad it worked. When I originally started in the emulator, I would have one shellcode that worked, and if I changed any tiny little thing, it would just crash into the debugger, and it was driving me nuts. Now it's working the way it should. You can write code that does the same thing, and it will work. Anyway, so that's the bind shellcode. And by the way, the port number, I should mention something about these values at the end are going to come back to make trouble. Okay, I need to have an IP address. Now, I could put in the real IP address, 192.168, whatever that is, but if you put in 0000, it will listen on all adapters, and that's what I usually do because I don't care. Of course, that means I have 32 bits of null here in case I care about embedded nulls. And here is the port number, and the port number, now, normally things are little endian, like this is the number 2. So it's 0200. The small bytes are 2 and the big bytes are 0 because it's an integer stored in little endian. Now in the same data structure, the next 2 bytes are the other way because they are in network order. And on the network, the most significant byte goes first. And just to make you all cry, the official standard here has 1 format for this and 1 format for that. So at first I had the port numbers all wrong because I couldn't believe this. I thought this had to be the little byte and that had to be a big byte, but it really is this way. 11 times 256 plus 5 times 16 plus 12 is 4444. So figuring out the port numbers is a little mind bending. Anyway, and you have to send an address to this junk in these socket calls. So you'll find that structure address referred to up here someplace. Well, I thought you would. Here's structure address. There it is. It's put here in R1. And a bunch of these calls, of course, refer to it. That's your socket handle, and you have to keep referring to it as you call bind and accept and all that stuff. So anyway, now we compile that the same way with assemble and load, and then we can run it. And so it assembles and loads. Now, if I run bind, it will just freeze up my machine. I put the ampersand there to get the cursor back, because now I can do things like say netstat minus AN, and I can put it through more if I want to be old fashioned and sleazy, and I will see that it is listening on 4444 somewhere. There it is. It's listening. Now, if you want to quit using deprecated functions like netstat and ifconfig, the cool way, of course, is ss minus pant pipe grep 4444, and then you'll see that. Anyway, you can there's many ways to do it, but this shows me that I'm in fact listening on that address, and I think I use a B here to see the binary. Yeah, then it'll actually, nope, not, anyway. So, all right. And I can use the shellcode. Since I put it in the background, I can just do netcat to 127.0.0.1.44.44. And now it didn't connect. How rude. Should have connected. But this one, is this one supposed to fail? No, I think this one's actually supposed to work. Anyway, all right, it should have connected. Something bad happened. I don't think I'm going to worry about it too much for we're on road here. It's still listening, and it looks like I have a connection. Time wait. Huh. Well, yeah, I think it did connect, but it loaded the same shell. I expected it to look different or something, because now I exited it and I'm still on. I think I might even be 2 layers deep. No, it was only 1 layer deep. Anyway, so I'm going to connect back in with my not Raspberry. Okay. Anyway, so all right, and now you can put that in exploit and run it and see it go, and you will now see the bind shell. You can run it in the debugger and see it go and all that jazz. So it works just fine, and that's the first one. Now the thing is, we have all those sneaking null bytes. And to get rid of them, the first thing we're going to do is completely insane. Now I'm planning several more projects that will get gradually less and less insane. But the first way to do it is self-modifying code, which is a blast from the past. I used to write this stuff in the 80s, and it's considered horrible. No one in their right mind would ever do it anymore. And in fact, there's yet another defense to stop us from doing this. This is evil, what we're about to do. But so we turned off ASLR, and we have this shellcode. And if you look at that shellcode, it is all full of zeros. Nulls here, nulls here, nulls here. Half the instructions have nulls in the middle of them. You can't inject this stuff into a string. This is kind of for the birds. So we should talk about thumb mode. Now, thumb mode is kind of mind-bending in itself. When I first saw this, I couldn't understand it. Here's how it works. Remember how every instruction is 16 bytes long, and they're all, or 32 bits long, and they're all on word boundaries. So if you were to do a jump or a branch or something, you can't jump to an arbitrary address. You only jump to a boundary within those 32-bit words. So what would happen if you tried to jump ahead by 1 byte? That wouldn't make any sense. So they use that to enter thumb mode. You branch 1 byte ahead, which makes no sense at all. And that is the clue to don't go 1 byte ahead, don't go anywhere, but instead turn into thumb mode. And thumb mode is where you have 16 bits for command instead of 32 bits. So of course you can't fit all the commands. So if you go to the ARM reference manual, there's a limited set of instructions available in thumb mode. You can't do as many different things anymore. And a bunch, but anyway, now that you're only 16 bytes big, I don't know why this mode even exists. Maybe there was once a 16-bit ARM processor, and this is for legacy code or something. But anyway, it's good for us because there isn't all this stinking embedded nulls. So now you have a bunch of commands to just do the same stuff. Socket 210, you load 210. You have the same old mess. You have to load 200 and add 81 to get to a big number. And then you call service. Now the service call, 0, has a bunch of zeros in it. And like I say, this number is ignored anyway. So you can just as well call service of 1, and it will do the same thing, and the command won't have a 0 in it anymore. So by entering thumb mode and using service 1, I've eliminated a lot of the zeros. So you compile that junk and show that it works, which it does. And then you can look at the code with objdump, and you'll see now the first 2 commands are in 32-bit mode, but there are no embedded zeros. Those 2 zeros are in different bytes. And then you go to thumb mode, and because there's only 16 bits per instruction, there's no embedded zeros anymore. Even if I do this where I add 0 to R3 and stuff, it doesn't refer to the 0 directly. So that's pretty cool. However, if you go down to the bottom, I have data sections. And of course, the data sections have this address, which is 32 bits of 0. And they have a number here, which is the 16-bit integer 2, which must have a null byte there. And down here, I need a null byte at the string. So the data section is a problem. It's got a bunch of nulls, and I really need those nulls. So the insane solution is self-modifying code. And I used to do this long, long ago before I knew what was horrible about it. So what you do is you put data in that doesn't contain nulls. You put in 1111 instead of 0000, and you put an FF there instead of a null, and you put an X there instead of a null. There, now my code doesn't have any nulls in it, but it won't run. It's totally wrong. Yeah.
So why did you put a comma instead of null?
That's what you have to do. That's the format. If you specify bytes, it's this. Now you could put, you could probably put like the big number here. You might be able to do it this way, but for some reason you don't want to do it that way. It's a good question. It's just those 4 bytes in a row. I don't know what would happen if you just used this and made it ASCII. Maybe it would work. The reason why, if you're a good programmer, you always use exactly the right word because then it'll port into other platforms or something. That's the point. If you're a sleazy shellcoder, that doesn't really matter. Yeah.
So you add what to your FF to get a 0?
You could. And in fact, that's where I'm planning to go. What we're going to do here is we're just going to overwrite those ones with 0. But what I did before, I had this actually almost working in the emulator, is I made like the Caesar cipher and the XOR encryption. And the cool thing about that is we can make ways to sneak viruses past antivirus with that stuff. And so I thought that was awesome. And that's where I wanted to go. I haven't bothered to get there, but I headed that direction. But this one here, we're just going to do the simplest thing. We're just going to add a few commands that put 0 on those null bytes. So here is one. You load R0 to the address of spawn, which is this, and then you just write null byte onto it, 7 bytes along. By the way, here's something that I couldn't believe until I checked. This command address takes the address from the right argument and puts it in the left argument. This command called store takes the contents of the left argument and puts it on the right. Remember how Intel format has the destination on the left and AT&T has it on the right or something? ARM randomly changes it from one to the other for each category of instruction just to give you a headache. And it's worse than that. There are ARM commands where you store R1 into R2 modified by R3, and it changes several of those registers. You can write to more than one register with the same command. The first couple times this happened, I thought I was losing my mind. You have to read the reference manual. There are versions of it that change this register and that register and maybe the next one. It's really strange. Of course, that would be really efficient if you understand it. But if you just try to write ARM by thinking you're writing x86 and choosing what looks like the same command, you end up in deep, dark, awful places pretty fast. Anyway, so that's what this does. There's a series of other things up here. This puts a null byte in there. This writes. So R1 is, R2 is 0. Because up here we did an exclusive OR of R2 with R2, where you take R2, exclusive OR R2, and store the result in R2. So now it's got a 0. So now we put the single byte of R2 here to make the high order of that integer for the index number that's supposed to be 2. And here we write the whole word, 32 bits of R2 there to get the whole IP address in one go. And in both cases, we don't have to explicitly refer to a 0, which would probably create a null byte. Anyway, that's the game. And so you can compile that stuff and run it, and it works. And like I say, it's interesting to look at the memory protections. You can see the memory protections in the debugger. I thought this is pretty awesome. So you run the code in the debugger, you put in a breakpoint, so it's running. Then you can use shell commands inside the debugger with shell. So you can run a process and see the process of your bind 3. It's 1384. And in the debugger, you can look at the maps. So here's the maps, and you can see that the stack has read, write, and execute, but my variables are in the text section. Remember, we didn't put them anywhere else. We put them right in the text section. So the text section is read and execute, but not write. So this shell code will not run. In fact, when you try to run it, it crashes here with a segmentation fault. As soon as it tries to write onto those variables, putting null bytes in, it quits. It says, wait a minute, you can't write there. What kind of idiot are you anyway? Self-modifying shellcode is for lunatics. So we've hit another defense. Now, there are a lot of ways around this. One thing I found a blog about this is to just push them on the stack and put it all on the stack, where you can get away with murder on the stack. That would be cool. But anyway, what we're going to do here is just turn off that memory protection. And you do that by just loading it with the -n flag. The -n flag says, let me modify the text section for self-modifying code. So that will, then it'll just run and work fine. Of course, we've turned off ASLR. We've turned off not modifying the text section. So we're in the kiddie pool right now. But you know, there are ways to get back. And now that I've got a debugger that works, I'm planning to get it. So I go to real ejectable text. I put it in the stack. I go to return-oriented programming to overcome ASLR. We can really go as far as we went with x86 and x64 with ARM, and then I got to do it with ARM64. So anyway, that's as far as I got here, and I thought it was good, clean fun. I'm planning, now I have some ARM devices that are permanently in the cloud. I put one over there and I connect it to Wi-Fi, and so I'm going to have challenges where you take over my real servers, which are going to be those Raspberry Pis just sitting there connected to the cloud to the Kitty College network. And anyway, that's the game. So, and I did make one where you have to make a real shell, make a real cloud command and control server on the cloud, and make a real reverse shell that phones home. You can do that. And here's a self-modifying reverse shell in the same spirit that has the IP address and junk down here. And then you can connect to your reverse shell. And that's what, and then I'm going to have a real Pi for you to take over. So that's the game. So I think you should check this stuff out, and the people that you here in the room should build some Pis. How many of you used Raspberry Pis before? Yeah, well then, you may not be interested. You can just use my one in the cloud if you don't want to do it. If you haven't, you should build one. They're fun. It's like little kids playing with Lego, and it's a worthwhile thing to do. I learned something right before class. I was trying to set up another one, and it crashed, and I thought the cable was bad, and I replaced the cable, and then I pulled out the SD card, and it was burning hot, and I looked it up. This is a known defect. The SD cards are frequently fake and defective, and they turn boiling hot and burn up. And you just throw away the SD card and put in another one, and you're okay. That was interesting. I thought I must have done something wrong, but anyway.
I had Raspberry Pi 3B Plus, and I just wanted to see what got locked in it.
Yeah.
And it was the SD card. I'm like, what the heck, you know?
I know.
You know, why of all things, why does that get locked?
Yeah, I don't know either. I don't really understand exactly how the hardware works. But anyway, you can build them and exploit them here, or you can just use my one in the cloud. I'm planning to put more in the cloud and put vulnerable services on them and put like a remote debugger on them and have like the equivalent of ED202 all for ARM, but it's going to take me a little while to get there. So that's all I wanted to show you. I'm just going to say a word about jailbreaking iPhones. That was something I wanted to add tonight, but let me tell you what ended up with that. I put it here. You can jailbreak an iPhone, but you can't have much fun after that. This is the checkmate exploit. You have to have a Mac. You cannot use a PC. You have to install this checkmate exploit, and then you have to have an iPhone of the right model, although a lot of models will do. It can't be, it has to be 32-bit, so 64-bit, so it can't be an iPhone 4, and it can't be the very latest one because they finally patched this. So anything from like the 5 through the 10, and you can do some other devices like some iPads and stuff too. So then you just run this software and it just guides you through it. You just go here, you connect your device with a USB cable. It then tells you to click start. Then it tells you to hold some buttons. You have to hold like the volume up and this button for so long, and then let this button off and hold that button to enter firmware update mode, which is a common mode to recover the iPhone. Then it pushes modified firmware into the iPhone. That's how it works. And then you end up with this thing on your desktop, which is the CheckRain app. And you have to run the CheckRain app, and then you can install Cydia, which is what everybody wants to jailbreak their phone. Cydia is where you get all the special apps for jailbroken phones, which is where most people do. Most people do it not to hack the OS like I'm going to do, but to get like pirated games and apps, things that they don't like, which is fine. You can do that if you like, but I care about the OS. So once you do this, you can then install a few things like SSH. And now you can't restart your phone. If you restart your phone, it will be unjailbroken. This is a tethered jailbreak. Now you might think that you're safe, that restarting your phone cleans it off, but I don't believe that's true. I think if you install an app and restart your phone, it's still there, but I haven't tried that yet. Because the interesting question is, can you get the user data? And I've talked to the guy who developed the exploit. He didn't give me a straight answer. This exploit does not get you past the passcode. So I can't really get your emails and stuff with this exploit directly. But I think what I could do is run this exploit and then install an app that will like steal your key presses or something, and then reboot it so the jailbreak stops, and then I'll get in because I got a chance to put malware on the phone, but I don't really know if that's true. And I have not been able to get a straight answer from anybody. They said, oh, I'm ethical, I wouldn't develop anything like that. And I said, yeah, I don't care about that. I want to know, is it possible? And I haven't really heard a straight answer for that yet. And that's where the hard part gets. I was able to install OpenSSH and get a shell on the phone, but to have fun, I wanted to do things. Next thing I wanted to do is put my PWD throw count on there and compile it. And GCC is gone. And I said, wait a minute, how can GCC be gone? They have something called CLang instead. Well, I tried using that. That doesn't work either. About 3 generations ago, like 4 years ago, they took all the libraries off the phone. You can't compile any code on the phone. Of course, why would you do that? You're supposed to compile on the Mac and push the app down from the development environment like Xcode, but they made it all mind-boggling and baffling. You can't write a simple C program and compile it and run it on the phone anymore. Although when I put that on Twitter, screaming blasphemy, like, wait, they took away GCC. How am I supposed to live? And somebody said, oh, there was some way to put it back, but I couldn't find anybody's blog that wasn't like mind-boggling madness to put it back. And what's funny is everyone said, you're an idiot, of course it's gone. Like I explained here, and when I read that page, I can't understand a single word of it. And I said, he thinks that explained it to me? I didn't understand a word of that. What's going on here? And then I finally found a few hacking tools. Like there's a hacking tool that totally lets you see what's going on in the app. And I said, well, we'll do that kind of stuff. And none of them work either. They're for 32-bit phones. And none of the things that decrypt the app to see what's in the code work either, because of course they're only for old, you haven't been able to jailbreak phones for about 8 years, except for really old ones. So all the hacking tools are out of date. And they don't really work on the modern system. So, and this jailbreak is only 3 or 4 weeks old. So I think we need to wait 3 months for all the hackers to update their tools to properly hack this. But next semester, I'm teaching hacking mobile devices. And by then, I'm hoping I'll get at least 1 or 2 hacking platforms working, and we can totally go into these iPhone apps and go into the way we went at Android. I can totally get an Android. There's a thing called Drozer that lets you see right into the OS. You can see all the processes, you can see all the signals between apps, you can take apart the app, you can see the source code, you can see where the variables are, you can really find out what's going on. And there are things like that for iPhone, but not for any modern version. But I think by next semester there will be. So anyway, you can jailbreak an iPhone, but you can't have much fun with it yet as far as I can tell. Yeah.
Can you see the source code from 4 to 10 or 5 to 10?
Well, now you can see the source code of the OS, which is what this gives you. To see the source code of apps, you have to reverse Apple's encryption, which is on the apps. And there are tools that do that. And I think they haven't made it so those tools won't work anymore. They've just changed the OS. So those tools compiled in the old version won't run. We just need to sort of recompile them according to whatever the new technique is. I've solved Xcode. That's why my Mac doesn't work very well anymore, because I had to update to the latest version, which breaks everything. But anyway, I put Xcode on my Mac. Supposedly, if I get Xcode, I can compile whole apps in Xcode and push them onto my jailbroken phone, and that's my next plan. Somebody wrote an app to train you, a deliberately vulnerable app, damn vulnerable iOS app. And you can't put it on a modern phone, but you can supposedly compile it in a new version of Xcode and then put it on. That's what I'm trying to do. I tried to put on the crappiest app on earth, Equity Pandit, which is hilarious, but apparently they know what crap it is. You can't even get it in America. It's only in the Indian iOS store. So then I thought, can I make a VPN to India and appear to be in India and get it there? But I couldn't quite figure out how to do that. But anyway, the other thing I could do is find some sort of pirate site that will let me download the IPA. But anyway, then I decided, well, I'll try for the damn vulnerable app, and that didn't work either. And so I've been, poking at this. There's a lot of this, it's like pen testing. You try this, you try this, you try this, this door is shut, this door is shut, you try this. You just keep poking around until you find something that isn't broken, and you get in. Yeah.
Someone messaged you.
Oh, someone messaged me. Good. Let's see what the messages say. Thank you. What version of iOS is required on the Mac? Oh, well, for the jailbreak, it can be any version. For the, but to compile code, I have never succeeded yet, but I'm hoping the latest version of Xcode will do. Next semester, I will have something working, and I'll let you know. For the last 2 times I taught the hacking device class, I just pretty much wrote off iOS because we couldn't do anything fun. But we'll definitely be able to do something fun next semester. But so far, I haven't found any of the hacking tools that work on this thing. And no way to compile simple things. But the thing I might do in the meantime is I'm going to get a 64-bit Raspberry Pi so we can do 64-bit ARM in that environment. and that'll work. That's what I was going to do on the iPhone, but I don't have GCC, and so I don't know how to make simple little programs to attack.
Is any of your classes in spring being canceled?
Apparently not. Although I don't really believe anything the administration tells me here. They say they're not going to cancel any classes in spring, but they also said they would unless they got money, and then they refused to take the money. So it's just like Washington. What they say makes no sense. It's like, why even bother talking to them? But anyway, that's what they say. So I'll be here doing whatever happens next semester. What I've done in the past, and I'd probably do it again, is if they cancel my classes, I can just teach them anyway, because since they don't pay any attention, you can just come in here and teach a class and they never notice that it's not on the books. I've done that before. The way to succeed around here is to just ignore the management like they aren't there. Just do whatever you want to do and just ignore everything they say. That's the path to success in colleges. It's definitely not the path in the private sector, but in the public sector, that's what you do, because they have no idea what they're talking about. And they don't care about what happens here. All they care about is like what lies they told Sacramento. It's the same thing in Washington. They're incentivized to play political games, to play the Game of Thrones, to stab other people to rise up in power. And what actually is happening in the area they supposedly oversee is of no importance whatever. So it's just like kids whose parents are drunks. They aren't even looking at you, they aren't paying attention. You can just do whatever you want. As long as they don't notice you, they'll be fine. Anyway, yeah.
Could something happen to the administration if the governor's office or state department, college department wants to really crack down on something?
I have no idea. I do know that they fired everyone in the administration except the chancellor in order to have a purge to get only people that are loyal to him, I think. They've done this before. They fired everybody. They all have to reapply for their jobs so he can pick the people he likes. So I guess he has an agenda, which he doesn't seem to explain to anybody. So in his mind, this is the right thing to do. I think it may not be as directly evil as him taking a bribe from somebody who wants the land. He might just be this extinct thing that used to exist called a small government Republican. There used to be these people, they no longer exist as far as I can tell, that believe government should shrink and taxes should shrink. And we shouldn't be providing so many services. We should lower the amount of colleges and hospitals and everything so we don't have to pay so much tax. That used to be a standard Republican position. Under Trump, the Republican Party has completely abandoned it. But anyway, I think he might be going, he thinks he's doing the right thing, but nobody understands it. He doesn't explain it to anybody. But it's not a mistake. He seriously thinks we should take less money and shrink and have less classes. And he did this to the last 3 colleges he went to. He's on a crusade. He's like a corporate raider. Gary Hart was this way. I think one of the guys that ran for president. He would take over a company and he would fire everybody and sell the infrastructure and pocket the money and then buy another company to do the same thing. This is one, and these people regard themselves as productive. They're removing the weak. You know, they're like tigers culling the herd. It's legal and you can make a pile of money if you do it right. And our chancellor seems to be in the same vein. He joins your college in order to burn it down. And he goes from college to college doing that. Anyway, people are screaming and yelling a lot. I don't know what's going to come of it all. They're having emergency meetings and begging. And one thing I've learned is they don't want me at those meetings. I say things like this and people get mad at you, you know. This is not the way to get things done politically. Like I went to a conference call with some people and Richard Wu was there and he was like saying the same thing I said, but somehow when he says it, they like him. If I'd said it, they would have hated me. You know, politics is the art of like sticking in a knife so nicely that they don't notice, you know. Anyway. That's why I've heard, but I think Winston Churchill said, see, politics is the art of saying nice doggy, nice doggy, nice doggy while you find a rock. Anyway, any other questions? This is the last class. If you're still turning in homework, it's all officially due today. If you turn it in anytime in the next week, I'll take it, but you lose some points for it being late. If you need more time than that, you have to send an email and let me know you want to get it incomplete, which is fine with me. That'll give you several months to finish the class.
You say it's officially due tonight, but if they have it tonight.
Then you lose some points for being late, but we still get something for it. Yeah. And there's a whole bunch of extra credit, of course. You can do this stuff, which is extra credit. You can do Go.
That's including extra credit with those points?
Yeah. Yeah. Even extra credit's all due today. After this, extra credit, well, I'll still take it, but you lose something for being late.
Depends on the project, how the extra credit.
Yeah, I don't actually know the system. My grader made up a system and I didn't pay attention. But she has some perfectly logical system. I was totally sleazy. I always used to make it 5 points no matter how late it was, and she has more. Anyway, so I'm going to stop the share. And if people want to build their Raspberry Pis and exploit them here, they can. We have plenty of these things. All right, farewell.